Okay. So the next gas law every book does is a law called Charles's law. Charles's law looks at the temperature and volume relationship. Again, that's a comma. The temperature and volume relationship of gases. Since we're changing temperature and volume, the two that we have to hold constant are the number of moles, N, and the pressure, which is P. So what Charles noticed is if you say have a balloon, and we're going to call this V1, and you've got the balloon is tied off, and you have a certain number of moles of gas in it, and you heat this balloon up, we go from T1 to T2, which has increased, the volume of the balloon is going to get bigger. That's because the molecules are moving faster, they're hitting the sides of the container more often. The pressure is still the same because the pressure inside and outside the balloon is the same, but they're hitting the walls of the container more often, and they're causing the container to blow up a little bit. This is a linear relationship. As T goes up, B goes up. It's why they tell you to always fill your tires after they've been running around, after you've been driving for a while, because you want the tires to be up to running temperature so you don't overinflate them. Never mind, wrong law, forget that. Okay, so what Charles noticed is he had a linear relationship, that's supposed to be a straight line down there, if he plotted B versus T. And Charles was working, let's say between 0 and 100 degrees Celsius, which is out here. But he found that all of his gases had a straight line, and they all intersected at the same point. So here, Charles is working in this area, a manageable area. This is obviously not linear because he found these guys all intersected at negative 273 degrees Celsius. There's something really important about 273 Celsius. If you want to say, as Charles did, that volume is proportional to temperature, what happens if you go negative? These are negative numbers, right? Negative down here. That's not going to work. You can't have volume being proportional to something that's negative, right? Like negative 273 Celsius. So along comes Lord Kelvin, who goes, aha, there is something special about negative 273 Celsius. Negative 273 Celsius is absolute zero. Or the lowest possible attainable temperature, absolute zero. Negative 273 Celsius is actually called 0 kelvins. If you just write 0 Kelvin, it looks funny because it looks like you're writing okay. There's no degree sign after Kelvin. And whenever you're working with gases, you must use the Kelvin scale. So if you have Celsius, and you add 273 to it, you get Kelvin. So if you have 25 degrees Celsius plus 273, you get 298 Kelvin, which is room temperature. So this is one equation that's not really a gas equation, but that you are going to need to remember and be able to use for the rest of this chapter. Conversely, Kelvin minus 273 will give you degrees Celsius. Remember one or the other. Now, Charles's law. Since Charles said volume is proportional to temperature, so this is still Charles's law. The simplest statement of Charles's law without working it out is just V1 over T1 equals V2 over T2. This is the equation that you want to put in your collection of equations. V1 and V2 must match. You can use whatever units you want, milliliters, liters, quarts, doesn't matter. And T1 and T2 must be in Kelvin. So let's try a really quick problem for Charles's law. So we have a balloon with a volume of 4.75 liters at 25 degrees Celsius. The volume, we want to know what the volume is. At 40 degrees Celsius. Okay, so since you're going to have these equations, like I said, you're going to have 7 of them, and you're not going to be familiar with them, label things. Once you label things, you can go back and match what you have in the problem to the equation that you need. So 4.75 liters, that's a volume. We're going to call that V1. It's the first one mentioned. 25 degrees Celsius is a temperature. It's T1. We don't know V2, that's what we're being asked about. And T2 is 40 degrees Celsius. So you've got V1, T1, V2, T2. You go, aha, that's the equation I need. So what do you have to do first? You have to convert T1 and T2 to Kelvin. T1 is 25 plus 273, or 298 Kelvin. And T2 is 40 plus 273, which is 313 Kelvin. Now you're ready to start your problem. Since I am looking for V2, I'm going to isolate V2. That gives me V1 over T1 times T2 equals V1, equals V2. And now I can plug in the numbers that I have up here and solve for V2. V1 is 4.75 liters. T2 is 313 Kelvin. It really does help to have these things labeled. I want T1, which is 298 Kelvin. Kelvins cancel. You're left with volumes in liters. And when I take 475, multiply by 313, and divide by 298, I get 4.99 liters. So an example of Charles's law.